Okay, in today's lecture, we will learn how to index and select data with Pandas DataFrame library. So, indexing and selecting data helps us to efficiently retrieve specific rows, columns, or subset of data from a data frame. There are variety of ways to indexing and selecting data in Pandas DataFrame class. So indexing data, we will be using standard parentheses operator, and then for selecting data, first we will be using standard parentheses operator, and then we will be using lock attribute, and then iLock operator, and then we will be discussing some other useful methods as well. So starting from the importing the package, so I import pandas as PD, and then for this particular lecture, we will be using the NBA dataset, which I have already downloaded, and you can also download it from the link in the description of this video. So in order to download comma separated value file, you can use the read underscore CSV method to import uh, the data in your pandas data frame class. So storing this nba.csv dataset into the data frame class, we will be using the read underscore csv function. So PD is short for again panda data frame class. So we have imported this nba dataset into the data object, which actually is the an object of the data frame class. So now in order to see that data, we can see that there are about variety of columns here. Then there is a name column here, a team column, label here, number column, label here, position, label of the column, age, height, weight, college, and salary. Similarly, talking about the rows, then the rows indexes start from the 0 and it goes up to 456. So there are about 457 rows in total, and there are 9 columns. So in order to change the index, as you can see that the index number of the rows are by default starting from the 0 up to n minus 1. If we want to change the rows index to the name index, then we can use the method set underscore index, and within the small bracket and double quotation we can specify the name of the column. With the help of this particular statement, we can actually set the rows index to the name column index. So first we will display the old data, that is in which we have not set over custom index, and then after displaying the original data, we will be using the name of the object which we have created by setting the name column as the index of the rows. So let's see the results. So now first of all, you can see that the old data, in which each column heading is the basically an integer value, that is by default it starts from 0 index, goes up to n minus 1, in this case 456. So after using this particular statement, we have set the rows index as the values of data under the name column. So let's see the effect of this. So this is basically the effect after setting the name as the rows index value. So as you can see that each name value has been set as the row index of each row. So as an example, the value of the cell under the name column has been set as the row index for the row, the very first row, and then the second name for the second row, and third name for the third row, so on and so forth. So this is how you can set the custom index of the row table. So just in case if you want to reset to the original data, that is where name is the label of the column instead of the row indexes, as you can see in our original data. Here name is basically a column label, instead of the rows indexes. So if you want to reset this effect, then you can use the reset underscore index method. So if you reset the indexes and set drop is equal to false, then it will actually uh, discard the whole name column as well. So first, starting from the uh, drop index, drop is equal to false. Let's see the effect. So this is the data when we set the rows, when we set the name column as the index of the each row. So after resetting the indexes, so after resetting the indexes, so we can see that okay, so we made a slight mistake here. As we know that the updated data was named as the data underscore index underscore name, in which we have set the name as the index of each row. So we have to use this name here. So that will be data underscore index underscore now. So this object of the uh, data frame class contains the name column as the indexes of each row. So if we set drop is equal to false, then it won't delete this particular name column, and instead it will set the name column as the name as the column in the resultant data. So let's try both of it. So if we set drop is equal to true, it means that it will reset the rows indexes from 0 up to n minus 1, but it will also delete the previous indexes. So as you can see, this is the original, or this is the data in which we have set the name column as the indexes of the row. So as we reset the indexes back to default values, that is 0 up to n minus 1. So here we can see that there is no name column here. So the name column has been deleted instead of resetting back to its original place where it was actually a column. So that is why we will set drop is equal to false, so that it does not delete the name column. Instead, it set this name column as the column back to its original position. So now executing this code. So this is the data in which name was set as the index values of each row. So after resetting, we can see that name has been set back as the column label, and the new rows indexes has been set from 0 up to n minus 1. I would also like to mention that if you use a method dot head, so what actually it does is that it will show you the first 5 rows of the data. So by default, it shows you the first 5 rows of the data if you do not specify any integer values here. So just in case if I specify 7 here, that it means that it will show the first 7 rows for this particular object of the data frame class. So let's see the effect. So here you can see that for the data frame in which we set the name as the indexes of each row, here you can see that there are basically 7 rows. So 1, 2, 3, 4, 5, 6, 7. So similarly, if you set this head as the, if you do not set any value here, so it will by default give us the 5 initial rows of the data. So as you can see that we have created a test data, which is the object of the data frame class, and it's basically resetting the name indexes as the name column in the resultant data. And by mentioning false here, we mean that we do not want to delete this name column. Instead, we want to set it as the column in the resultant data. As a result, you can see that there are basically 5 rows here, 1 2 3 4 5, and name has been set as the column in the resultant data. So now indexing data uh, using the standard parentheses operator. So by indexing, we actually means that selecting data. So I will set it back as the selecting data as the using the standard parentheses operator. So basic syntax is that uh, we will use the angular bracket, and within the angular bracket we will provide a string value. As you know that single quotation or double quotation specified that this is a string value, and by string value mean that it is supposed to be the column of the uh, data in the data frame. So the standard bracket notation is used to select a single column from a data frame. Column name specifies the name of the column you want to access, and it basically returns a Panda series if you specify a single column name here, representing that it is a single column. To select multiple column, a list of column names should be provided instead of a single string. Now, some of the selection operations or selection techniques which are available to us using the standard bracket notation is that selecting a single column using standard brackets and selecting the multiple columns using the standard bracket. First, we will be selecting a single column using standard brackets. So the syntax is very simple. Before selecting the data, first we will display the original data. So data underscore index name. So we know that this object of the data frame class contains the name column as the indexes of each row, and we also specified head and an integer value of 5, which means that we want to display the first 5 rows of the resultant data frame. And then we want to create a new data frame, and in this will not be actually a data frame, but instead it will be a Pandas series object, because we have selected only a single column name here. So all the data under the each column will be sliced off from the original data and will be stored in the first object of the Panda series. So then we will be printing the Panda series object. So let's see the output. So this is basically the original data from which we have sliced off the age column. So by slicing off the age column will not affect the original data. Instead, it has been stored in the new object. So after selecting the age column or slicing off the age column, we can see all the data under the age column. So this is basically the index number, which is the name column values used as the index number for each row, and then there is this is the value of the data under the age. So all of the values under the age column has been sliced off and stored in the test object, and we can see that the name of this particular column is the age, and all these are values under the age. As you can see that we are using display function instead of the print function. So display function shows a richer output and more formatted output. So as you can see that we have used the uh, display function here, and this is basically the output of the display function, which is a much richer output. So if we set the display back to the print function, and we can see a massive change in the output, that we can see a conventional output of the print function, in which, because of the shortage of space, we can see that this particular output has been split into two. So the rest of the columns have been shown in the next line, that is the college and salary have been shown in the next line. So that is why we'll be preferring the display function instead of the print function where it is feasible. So now selecting multiple columns using the standard parentheses operator. So instead of providing a single column here, we have provided the uh, list of columns. As you know that these angular bracket specify that this is basically a list, and each column name within double quotation is behaving as a single element in this list, separate by the commas. So now what will happen is that these three columns and all the values under these three columns will be sliced off from the original data and will be stored in the uh, object named first. And this object will now be actually the data frame class, because this time we have sliced off multiple columns, so we can see the output in the form of the tabular format instead of the series data. So first we will display the original data, in which name will be acting as the index values for each row, and this head specifies that we only want to show the first five rows, sorry. And then the resultant data, we have also specified that we want to see the first five rows of the first object of the data frame class. So let's see the result. So in the result, you can see that this is the original data, in which we have only selected the first four rows. By selecting the first four rows, I mean to say that I have chosen to show the first five rows in the output. Instead, it does not change anything in the original data. And then after selecting the age, college, and salary columns from the original data and storing it into the new object, which we have named as the first. So if we remove the head, we can see all the data that is stored in the first object of the data frame class. So these are basically all the rows, and we can see first five rows and the last five rows, and all of the middle rows have been represented as the dotted lines. So these are basically 457 rows and 3 columns. Now, uh, indexing and selecting data with the help of the lock attribute. So this syntax for it is the, so I have corrected a spelling mistake here. So it is the selecting data with the help of the LOC. I will be calling it as the lock attribute. So the syntax will be is that first we'll write the name of the object of the data frame class, and then there will be dot operator, and then there will be the attribute lock, and within the angular bracket we can specify two things. The first thing will be the row labels, and the second thing will be the column labels. So we can see that if our data is labeled, that is each column is labeled and each row is labeled, then we cannot use indexes here. We must have to use the label. Instead, it will give us the if we do not do so, then it will basically return us the syntax error. So the lock attribute is used for label-based indexing. It allows us to access rows and columns by their labels. Unlike the indexing operator, it can select subset of rows and columns simultaneously, which offers flexibility in data retrieval. So previously we saw that the indexing operator, which is the standard parentheses operator, it can only allows us to select the column based selections, and it does not facilitate the rows based selections. So now we'll be using first the lock attribute to select a single row by label. So again, you can see that we are using the data in which the row is labeled with the names as indexes. So we have used lock keyword, and within the angular bracket we have specified a single name here. And what will happen is that in the resultant um, data, the only a single row in which the a in this particular index will be stored as a single row. And let's see the output. So you can see that this is the original data, and in this original data we have a row index named every Bradley, and we specified here that I only want to select this particular row and store it in the row object. So first we have output the original data, which we can see here, and the resultant data, in which you can see that this particular information is for the row whose index name is the average Bradley. So this is how you can select a single row, and then we can also select multiple rows by using their labels. So in this particular example, you can see that we have provided the list of labels, in which there are two labels. The first one is the Avery Bradley, and second one is the RJ Hunter. And then we want to show these two rows in the rows object of the data frame class. First, we will display the output for the original data, and then we will display the output for the selected two rows. So let's see the output. So this is basically the original data. We can see the names, the first name which we have provided as input here, and RJ Hunter is the actually in the fourth name here. So we selected specifically these two names, and then we have stored it in the new object, which is named as rows. And then we displayed the rows. So you can see that only these two rows have been selected, and now these two rows are acting as the new data frame. So now we can also select a range of rows by using their labels. So we have used the same attribute log attribute here, and then we have used the first index name, that is the every Bradley, and then we used a colon here. The colons means it is basically a range. So all the rows starting from this one and ending at this one will be selected from the original data, and they will be stored in the new data frame, which we set the name as the range of rows. First, we will display the original data, only the first 5 rows, and then we have displayed all the rows in the resultant data frame. So let's see the output. So this is basically the first row. So you can see the starting name is the average Bradley, and the ending name is RJ Hunter. So every Bradley is the starting name, and RJ Hunting is the ending name. So all the rows starting from this up to this will be selected and stored in the new object whose name is range of rows. So let's see the output of the new data. So as you can see that this new data frame contains only these 4 rows, but keep in mind that this is the original data, and this is not the only data that is, it's showing only the first 5 rows because we have used the head function here. So if we remove the head function from here, it will show the complete data of the original data. So here you can see that there are some dots. So these are the initial 5 rows and these are the ending 5 rows, and there are in total of 457 rows into 8 columns. Okay. Now to use the lock attributes to select specific rows and columns. So the method is very simple. As we know that the lock attribute can accept two things separated by a single comma. The first thing is the information regarding the rows, and the second thing is the information regarding the columns. So we can provide multiple rows and multiple columns here in the form of the list. So now here you can see that we have selected only 2 rows whose index name is the Avery Bradley and RJ Hunter, and then separated by a comma, which means that this is basically the list of the columns instead of the names of the rows. So we have selected team number and position columns, and we have selected indexes Average Bradley and Archer Hunter from the original, in which name has been set as the index value for the rows. So now we have selected the multiple rows and multiple columns and stored it in the selection data frame of the data frame class. First, we will output the data frame index underscore name object, which is the original data, and then the newly formed object data. So let's see the result. So this is basically the original data, and the new data frame contains only 2 rows whose index is this, which we have selected explicitly, and we have also selected the column labels explicitly that by specifying them in the angular bracket as a list. So this is how to select multiple rows and columns. So now if you want to select all rows and specific columns, then the solution is very simple. As you note that the lock attribute accepts two things. The first thing is the information regarding the rows, and the second thing is the information regarding the columns separated with a single column. So separated with a single comma. Okay. So if you specify the full colon and do not write anything else, it means that we aim to select all the rows in the data frame, and instead of selecting all the columns, we have specified the specific columns by incorporating a list and providing this list as an input here. So here you can see that we have used a full colon here, which means that we want to select all the rows, and we have specified 3 columns in the form of a list. So only these 3 columns will be selected and all the rows will be selected. Now this is the output. So here you can see this is the original data, and only first 5 rows have been shown here because of the head function, but we have not used the head function for the resultant data frame. So the resultant data frame contains only 3 columns and all the rows. So you can see that there are in total 457 rows and 3 columns. So these columns are explicitly selected by us using the lock attribute. Now there is another attribute with the name ilock. So the alphabet I is short for indexed base selection. So using the same kind of syntax, now we'll be using angular brackets here as well. So instead of representing rows as the index number, we will be using the index numbers here, and similarly we will also be using the uh, column positions here in the form of the integers. iLook attribute is used for position-based indexing. It allows us to access rows and columns by their integer positions. It is similar to log, but only accepts integer-based indices to specify rows and columns. So now, by using iLoc attribute, we will be selecting a single row by position. So first we will be displaying the original data, but only the first 5 rows of the original data. So now you can see that this original data does not have any labeled rows, which means that the default rows indexes will be used starting from 0 up to n minus 1, and similar will be the case with the but sorry, not similar case with the columns, but the columns do have labels, but because we are using the iLoc attribute, so we can also specify the integer numbers for the column indexes as well. So this is a simple version in which we have only specified 3 here. So if we do not specify anything else and we do not use a single comma here, then this 3 will be used for the representation of the row index. So it means that index number 3, as we know that the indexes start from 0. So if we count, then it is basically the 4th row, and whose index is 3 will be stored in the row underscore 3 data object, and then we will display that object only. So this resultant object will contain only a single row. So this is the original data. In this original data, you can see that name has been used as a column label instead of the row label, and all of the row labels are the default indexes starting from 0 up to n minus 1. But since we have used the head function here, so only 5 rows of this particular data frame is shown here. So after selecting a particular row, we can see now that this particular row here, and this is the index number of the row. So we have selected the index number 3, and this is the data of the index number 3 row. So the name of the index number 3 is RJ Hunter. The data under the team column is Boston. The data under the number column is 28. SG under the position column, 22 is under the age labeled column, 6 to 5 underscore under the label of the height column, so on and so forth. Now, if you want to select multiple rows, then the answer is very simple. Instead of providing a single indexes, we will be providing multiple indexes in the form of a list, and then the resultant data frame will contain the information regarding the row index number 3, 5, and 7. So let's see the output. So this is the original data, and only first 5 rows of the original data has been shown here because we have used a head function here. And this is the resultant data in which we have used the row index number 3, 5, and 7, or we have selected row index number 3, 5, and 7. But just in case if we want to reset the indexes from 0 up to n minus 1, what we can do here is that we can use a method here, reset underscore index, and drop is equal to 2, because we do not want to keep track of the previous indexes, that is these 3, 5, 7. Instead, we want to reset these indexes from 0, 1, and 2. Just for the sake of understanding, if we set this drop is equal to false, what will happen is that previous indexes will be incorporated as a new column here. So as you can see that 3, 5, 7 have been selected. So this is the output of this particular display function. And after resetting the indexes, we can see that as we set the drop is equal to false, the previous indexes have not been deleted. Instead, they have been incorporated as a new column here. So in cases where you do not need the previous indexes, then you have to set this drop is equal to true. In this particular manner, you will be able to delete the previous indexes and reset the indexes from default values, that is starting from 0 up to n minus 1. In this case, the n is 3, so that is why we can see the maximum index number of the row is 2 here. Now, in order to select range of rows and all columns, what we can do here is that we can specify a range here, that is to select the index number 0 up to 5 minus 1. So please keep remember that this particular value will not be incorporated as the row number here. Instead, what will happen is that by using this range, rows from indexes number 1 to up to 4 will be selected, and index number 5 row will not be selected. And here you can see that in the second portion, which is separated by single comma, we have used a full colon here, which means that we want to select all the columns. So now again, first we will display the original data, and as we can see that we have used a head method here, so only first 5 rows will be displayed, and then the resultant object which has been newly created here, in which only first 5 rows are selected and all columns selected, will be displayed on the output. But since we know that but since we use the range of rows here, so we specified the range from 0 full colon 5, and we know that that fifth index row is not added here. So since these indexes are already in the you can say ascending orders, we in this particular case we do not have to reset the indexes. But in cases where we want to select the rows from, let's suppose, 3 to 7, which means that 7 will not be included, but index number 3, 4, 5, and 6 will be selected. In total, 4 rows will be selected, and the resultant data frame will be like this, in which 3, 4, 5, 6 will be selected. But if we want to reset the indexes from 0 up to n minus 1, then we have to use the reset underscore index method here, in which drop is equal to true, which means that we do not want to keep track of the previous indexes. So here we can see the output in which these indexes have been reset from 0 up to n minus 1. So now, in order to select specific rows and specific columns by position, it is very simple. You have to specify the list of rows and then the list of columns. So here you can see that you have specified only 2 rows here, that is with row index number 3 and row with index number 4, and 2 columns here with column index number 1 and column index number 2, which means that the column number 2 and 3 will be selected. First, we will be printing the original data with only first 5 rows, and then we will be displaying the newly selected data by using the display function. Yeah. So this is the output. You can see that this is the original data with the only first 5 rows has been displayed here, and the resultant data contains only 2 columns. So this is basically column index number 1, and this is the column index number 2, and we have skipped the column index number 0 and the rest of the indexes as well. And you can see the only row index number 3 and row index number 4 have also been selected. Now to select all the rows and specific columns, so this is very simple. First, we have to specify the full column here, which means all the rows and the list of the indexes for the specific columns. So the resultant data will contain only the uh, uh, column index number 1 and 2 respectively, which is the team label and number label, and all the rows starting from 0 up to 456 index numbers. So there are some other useful indexing methods. So first we'll be discussing the head method, which we also saw that head method is used for selecting the starting rows. If we do not specify any value here, then only first 5 rows will be displayed, and if we specify specific value here, and then rows up to the specific value will be showing the output only, but it does not modify the original data. And tail is the opposite of the head. So if we use a tail without specifying any number here, so then this tail method will be displaying the will be displaying the last rows only. So as we have specified 3, so it is displaying the last 3 rows here. So if we do not specify any number here, it will be displaying the last 5 rows by default. And if we specify 7 here, it will be displaying last 7 rows respectively. Okay. So now let's discuss the at attribute. So the at attribute basically specifies the row label and column label, but you can only specify single row label here and single column label here. So because we are talking about the label, so we are not using the simple data. Instead, we are using a data in which name has been set as the row indexes. So first we will be displaying the first 5 rows of the indexed data, and then by using the add attribute, first we have selected a single row here, and within that single row we have selected only a single column value here. So in the output we will be able to see only the age of this particular row whose index label is Avery Bradley. So this is the resultant value here, and which is the 25.0. So we can see that the uh, Avery Bradley row under the age, we can see that 25.0 is here as well. So this is how you can select single data from a data frame. Likewise, you can also select a single data from the whole data frame by using the index number. So first you have to specify the row index here and then the column index here. So as you can see, we are using the data in which we do not need the rows label as the column labels. So it means that this data contains the default values of the row indexes, that is starting from 0 up to n minus 1. And then we have specified that we want to uh, select the data next to the row index number 1 and under the uh, column in with index 3. So again it will select the SF because as we have specified row index number 1 and column index number 3. So this is column index number 0, 1, 2, and 3. So this is the value here, and we can also see the output of this particular selection, which is the SF. Now there is another method of the data frame class, which is the pop method. So it basically removes specified column and data frame, returns the removed column as a Pandas series, and it also modifies the original data frame in place. So the syntax is very simple. First, we have to specify the uh, data frame name, and then using a dot operator, name of the method, which is the pop method. Under this small bracket, we have to specify a column label. So in order to do that, first we'll be creating a test data, and by using the range of rows starting from the index number 4 up to index number 5, and then all the columns, first we'll be displaying the test data. So here we can see the test data here. So the test data contains only the first 4 rows, and sorry, this is, yes, this is the test data. And then we have created a series from this test data by popping the age column. So if we pop the age column, it will be stored as a series in this particular object. So now we have displayed the series here. So you can see all the data under the age column which has been popped from the original data. So now we want to see what happened with the original data. So the original data now does not contain any column with the label age. So you cannot see the age label here. So instead this age label has been stored as the series object, which we have displayed here. Now there is another method with the name drop, and we have also already used it a lot of times. So syntax is index underscore label if the indexes are labeled, and this is basically used for the uh, rows, not the columns. So you can drop a particular row if it is labeled, and if it's not labeled, then you can specify the uh, row index default values, which should be an integer value. And you can also use the drop is equal to true for renumbering the indexes from 0 to n label. So again, first we have created a test data from the data in which the row indexes have been set as the column label data. And then by using the iLocation, we have selected the data from indexes up to 0 to 4, and we know that 5 index number 5 of the row will not be included in all the columns here. First we'll be displaying the test data, so see what happens with the test data. So this is the output of the test data before any modifications. So now we have reset the index. So we have reset the index in which drop is equal to false, which means that the name column has been used as the index of the rows. It should be set back as the column label and will not be deleted. So we can see the resultant output that if the drop is equal to has been set as the false, then name column will be set back to its column label, and all the rows indexes will be reset back to the uh, integer indexes starting from 0 to -1. Similarly, if you specify test data drop is equal to 1, it will remove the row from the data frame. So now you can see that after dropping the index number 1 of the row, we cannot see any index of the row with the value 1 here. And similarly, we can set the indexes back to true after dropping it. So this is the test data. So as you can see that these indexes are not in ascending order anymore because one has been deleted, so one is missing here. So if we want to reset the indexes back from 0 up to n-1, then we have to set drop is equal to true so that the previous indexes are not stored as the new column. As a result, we can see that the previous indexes have been deleted and the new indexes have been set here from 0 up to n-1. So now there is another method, which is the get method. To get an item from object for a given key, the key could not be more than one data frame column. It returns default value if not found. So again, it requires only the column label. It does not work with the, I guess, row label. So again, uh, we are storing the age label data in the uh, newly created object, that is the test data, and then outputting the test data. So we can see that all the data under the age column has been set as has been stored in the test data. So this is how the get method works. So now what we are doing is that we are storing the original data in the test data by selecting all the rows and all the columns from the original data in which The rows indexes are from up to 0 up to n-1. And then first we will display the original test data. So the test data is now exactly become to the original data which we have imported at the start of this lecture. Now what we are doing is that we are only selecting the age, team, and position columns, and then stored all these three columns and the resultant data to the new object, which is the new data. So that's how you can see it. And then we are using the insert method. So this is a very interesting method because it inserts a new column into data frame at a specified position, and it basically requires the index column index where we want to insert the new column, and then the column label which will be set as the new label, and the values under this new label. This particularly useful when we want to place a new column in a specific position instead of just appending it at the end. The syntax is that we just saw here. First we have to provide the location index here of the column, and then the column name here, and the values under the column. And if we want to allow the duplicates of multiple columns, then we have to set it as false, otherwise true. So let's see the very first example. First, we have created a data frame in which there is only a single column with the label capital A and uh, only two uh, values under it. So this is the newly created data frame. So now we want to insert a new column at index 1. So as we know that this is the first column, so this is the index number 0. And by using the insert method, we want to create a new column that is the whose label will be capital B, and it will be inserted at the index number 1, and it will contain only a single value, that is 100. So it means that if we want to see the new data frame, since we have not specified a list here, so all the values under this B column will be set as 100. So you have to keep remember that if you specify a single value here, then all the values under this particular column label will be set as this particular value, as we just saw in this case. So now again, creating a data frame which will contain only a single column and the values 1 and 2 respectively under it. And if we want to insert a new column at index 1, which means that it's basically a different index than this one, because this A will be uh, so let's see, first let's display the data frame after inserting a new column. So this is df. Okay, so this is the newly created data frame, and we can see that the column index here is basically 0. So now we want to insert a new column with exactly the same column name, that is A, and at a new index, that is 1, so that it does not completely override the previous column with the values 3 and 4. But remember that we have also allowed duplicate hairs because we have now set its value true. So it means that a new column will be added with exactly the same name as the previous column. Okay, so this is an example. We are creating a new data frame from a dictionary in which there will be two columns. The first column name will be B and the second column name will be C. So now we want to insert a new column and index 1, but we already know that there is a column label C at this particular location. So first we will display the df without inserting any column. So this is the data frame without inserting any column. It contains the column labeled B at index 0 and the column labeled C labeled as capital C. So now we wish to insert a new column with the label capital A and index 1. We already know that there is a column already exists at the index 1, which is C. But what will happen here is that by inserting a new column at index 1, so index 1 will be inserted at this particular index, and the column C will be shifted to the next index, that is the index number 2. So this is it for today's lecture. So if there is any question, you can ask.